Hello and welcome to the Daily Space, coming to you live and with audio this time from Vienna, Austria. We have had some periodic technical issues because I'm using hotel Wi-Fi. I'm going to keep an eye on my kilobytes per second and hope for no dropped frames this time. So thank you all for your patience, and you get me with weird lighting so you can see the sunset behind me. We are on the shores of the Danube River, and there are literally thousands of astronomers who are oscillating back and forth between discussing the politics of our union, discussing how science has advanced in the past 3 years, how it's going to advance into the future as we plan out our 10-year strategic plan. And then they're exploring all of Vienna. And I'm not sure there's a coffee shop in the city where you can go and not find an astronomer. Now, for the past 2 days, for the past 2 conference days, last Friday and today, the meeting has focused on the various divisions for what are called division days, or under a new referendum, planet days. These days, no matter what you choose to call them, are the days that we come together organized by our thematic groups. So we have, for instance, the division that I'm an officer in, Division C. We are the committee that is rather haphazard. We are the division of education, public outreach, diversity, and history. So pick all of the above or one of the above and come join us as we figure out how to remember where we've been, to hold on to our history as something we can learn from. And in the case of supernova, something we can just plain study. And as we work to figure out how do we educate future generations and communicate out to this generation all the things that are taking place as we advance our fields. Other commissions and divisions focus on things ranging from the local galaxy, so our own Milky Way and the dwarf galaxies that surround it, to, fundamentals of measurement. How is it that we devise our coordinate systems and measure the exact positions of stars? There are a myriad of different groups, and you can get a taste of all of them by going to the International Astronomical Union's newspaper, which, if I'd been smart, I would have pulled up ahead of time. It's at astronomy2018.cosmoquest.org. And if that URL seems a little bit familiar, it's because it's our CosmoQuest website, and the Daily Space is brought to you as part of CosmoQuest. Now I need to rejigger my screen a little bit so that you can see some of this. So over on our newspaper, we have the ability for you to go in and click on the different divisions and get a complete listing of the articles that have been submitted. Now, we are missing a few divisions. This isn't because we didn't like them or they're boring. It's simply a matter of they didn't get their articles submitted. And so go check out what we're doing, from fundamental astronomy to the sun and the heliosphere, to planetary systems and bioastronomy, which is an old word for astrobiology. It's all right here. So I see Larry asking, are past e-newsletters or this is the first fully electronic, laid out electronically, WordPress-based site that we've ever had for the IAU. We have had in the past regular everyday newspapers, and all of these can be found off of, I'm trying to figure out where they are. One moment, and I can link to all of them. Here we go. So I will drop the link in to the chat And yes, huge chat is huge. I have no clue how that happened. That is fascinating. Okay, tonight we're going to have a huge chat. I'm good with that. I hope you're good with that. Clearly some work is going to be need to be done at some point. I don't think there's coffee on my face. I really don't. There's coffee pretty much everywhere. I have no clue how that embiggened the way it did. So let's go back. Thank you so much for the thing that just occurred. Thank you, Scott, for subscribing for 4 months in a row. That's awesome. Okay, so the link that I just sent you will take you over to all of our past newsletters. There we go. I'm going to make this fit on your screen. Thank you, Scott. So, well, back in 2015, the first time I was on the staff of the newspaper, we did go green, and we only had our newspaper as a PDF. In the past, PDFs like that would have been printed out every single day. And in fact, the original issues of the newspaper, the first one coming out in Moscow, these were actual newspapers. They were printed in multiple languages, and I'm really glad we don't have to do this much layout work anymore. Thank you so much, Guido. That's awesome. So here is one of our oldest newspapers, and all of these are yours to explore at the IAU website. And like I said, I gave you the links. So once upon a time, Keeper of Maps, the official languages of these meetings were Russian, English, and French. This is part of why the IAU symbol is UAIIAU. This is because in French, the words go in a different order. And so they created a logo that represents all three of these things. Now, over the years for the newspaper, the languages have changed. And by the late 80s, the newspaper was done predominantly in English. I was not part of the society. I can't not tell you the debates that occurred that led to that. I do know this makes my job easier. So we are not, Graham, we are not voting on Pluto this year. I'm so sorry. The resolutions that we're working on instead have to do with the fundamental coordinate system that is used to describe what's going on up at geocentric orbit. We're going to define the coordinate system a little bit more precisely now that we have better tools for doing these kinds of measurements. There are others. All of these are in the newspaper. Let me pull them up on the newspaper so that I don't forget any of them. So, resolutions to be voted on. So we have a 10-year strategic plan that we're going to be voting on, which lays forth the goals during the next decade for our union. Here, as I said, we have a resolution on the geocentric and international terrestrial reference frame systems and frames. So that's a fancy way of saying we're going to make sure we actually can take advantage of all the details that we get from various technologies to define where things are in geocentric orbits. Then the third one on celestial reference frames is just working to refine exactly how it is that we describe where things are in the sky. B3 is going to be discussing how it is that we make sure we keep all of the old measurements, all of the old data, so that it's there when we want to go back and see how was the star behaving in the past. These kinds of records have been exceedingly important, and you may have even been familiar with some of how they've been used. For instance, with Tabby's star, Brad Schaefer from Louisiana State University did a dig through a lot of the historical data to show that over decades, Tabby's star has been slowly decreasing in brightness. And the final one, B4, it's a proposal that will be this year's controversial proposal. And the idea is, will we or will we not change how we refer to the plots describing the expansion of the universe and how things that are further away appear to be moving faster away? They only appear to be, they aren't actually, it's the universe carrying them. And the reason that this is coming up is there's records that show Lemaitre, or Lemaitre, I'm not sure of the pronunciation, originally forecast this as a prediction of what should be seen if we're in an expanding universe, and that was a natural outcome of many of the theories to describe cosmology at the time. There are evidence that Lemaitre discussed this with Hubble during an early International Astronomical Union meeting, and that it could be the two of them influenced one another's understandings, and that because of this mutual, theoretical and observational work that they did, it should be referred to as the Hubble-Lemaitre law instead of just the Hubble law. So, not wanting to cause a hoopla as happened back in 2006 with the voting on Pluto, what has been decided is we're going to do an initial vote by hand during the GA, and then all members will be asked to vote electronically so that there's no bias against people who couldn't afford to stay until Thursday, or who perhaps couldn't afford to come at all. So we're working to make things, more democratic in how we do our science. So those are the resolutions this year. So far, Hanny, we aren't working to do any digitization of old data using AI. There are some Talmud studies that are working to do that, and I think a lot of people are waiting to see how successful those are. The same technology that you use to preserve religious records and use it to look for trends, look for signs that different things were written by the same hand. These are similar technologies to what you can use to preserve any handwritten records, observing logs and the like. So these are, they're happening. We're just waiting to see what happens. Yes, Graham, Katherine Johnson did calculate a lot of those trajectories by hand. I don't know about that one in particular. I know that she was influential on the Apollo missions. Astro YYZ is saying, looking through old criminal cases using new DNA tech. There's so many different things that are benefiting from our ability to digitize old records. And in astronomy, we are in the process of trying to digitize many of the glass plate collections so that they can be used in multiple locations. The first great part of doing this was the digitization of the Palomar All-Sky surveys, north and south. That luckily has been digitized. Well, I don't know when it was digitized, but I know I was able to use it for my dissertation work. So that was late 90s, early 2000s. Now we just need to wait and see what happens as we get all of these records online and hopefully in a format that we can use. This is one of our great struggles, is every telescope seems to have its own way of storing data. Various teams have been working for over a decade on how we should bring everything together under an international virtual observatory program to use consistent metadata. We're not there yet. We're working on it. So anyways, today was all about the division meetings. And as we move into the week, we're going to continue to have more things going on. We're going to keep bringing you all the things we can from the meeting, ranging from, of course, a roundup of the tweets, because that's fun. And, well, we enjoy doing that as editors, to celebrating the various discourses that are going on and, well, bringing attention to various issues within our community. There was a young astronomers lunch earlier that was set up to help young people figure out how exactly do you make it in this day and age where jobs are scarce and the desire to be an astronomer is strong. To now we're moving on to having a women's lunch, and yeah, there's stuff going on all over the place. Okay, so there is other news going on in our field, and I'm going to do a quick roundup of the news and be completely baffled at what's going on in the chat. This is deeply, deeply confusing. And like the chat is hanging off the bottom of the screen. Yeah, I don't know what's going on here. Let me at least make this a little bit smaller. That's too small. Okay, I'm going to go with that and move the chat behind. No, I'm just going to do that. I will sort all of this out before I stream again. I did update OBS right before this stream, and apparently the updates caused strange things to happen. And the chat could totally have been learning from Skycam. I did bring Skycam with me on this trip, and you're talking to me on Skycam. Anyways, so moving on to some of our latest news coming. Well, because news keeps coming even when you're at a science conference. In the first story that I have today, I am bringing you updates. I'm not leaving the Skycam in Vienna. I'm bringing you updates from the Planetary Science Institute. One of their team scientists did what is a really fascinating bit of research that wasn't entirely the kind of thing that many of us expected to see, that is evidence of just how much creativity is needed to make some breakthroughs. In this particular case, PSI Associate Research Scientist Elizabeth Jensen's team was catching radio signals from the Messenger spacecraft as it orbited Mercury. And its signals were a bit perturbed, is how I'm going to choose to describe it. And in trying to figure out what happened to their radio signals, what they realized is coronal mass ejections, as shown in these images. Coronal mass ejections that took place filling the space between us and the Messenger spacecraft had an extra tail of interference that, well, worked its effects on those radio transmissions. This means that we were able to discover trailing components of coronal mass ejections, not because we had a spacecraft out there observing them, not because we were in a position to observe them, but simply because Messenger, where it was located, had its data passing through this region of space where we never expected interference, or at least I didn't know we expected any interference. And because the signals were interfered with in a way that could be measured, we now know that coronal mass ejections have new shapes, have new, well, ways of wreaking havoc on our radio transmissions. The more we look at coronal mass ejections, the more wild and hard to explain they become. Hopefully, with the Parker Solar Probe on its way towards its encounters with Venus and the Sun, hopefully we'll slowly be able to come up with more and more explanations of exactly what's going on. Now, in other solar news, I forgot to drop the picture in, so pardon me for a moment while I grab the picture I want to show you. Now, some of you may have been involved with taking images for various science projects during the last solar eclipse in July of 2017. Now, if you wanted to know what good your images were, I can show you exactly that in this image right here. This is a newly released image that is taken from Nature Astronomy. And what it does is it compares an image from Mitchell, Oregon, an image from Salem, Oregon, and the predicted polarized brightness that was developed from a variety of computer models, and also the predicted squishing factor, so how much the volume of the sun would appear reduced, the predicted magnetic field and the detailed lines from it, and the predicted, with a log sharp mask, the predicted brightness of the corona in general. Now, these predictions were made based on images that were taken in the days leading up to the eclipse that did not allow us to see this part of the corona. Using our ground-based and space-based images, we can see the surface of the sun, and we can see the outer region of the corona, but the inner region we have no way of getting to because it's so faint compared to the disk of the sun, and we can't safely block only the disk and see this inner part of the corona. With the eclipse, we had a unique opportunity, at least in terms of having that many stations spread across the United States, unique opportunity. We had a fabulous community of observers that were able to catch this data and compare our predictions for the shape of the corona to reality, and it turns out it matches. Now, I see folks asking exactly what does this tell us? Well, for now, it tells us we can actually piece together our data and build a continuous understanding of what's happening in between the surface and the outer corona. We understand how to put the pieces together and build that inner hidden region. Now, as we start to worry about how do magnetic flares change over time, as we work on building models that allow us to predict our solar system's weather that is caused by the sun acting out, this is one of those first stages. This is like that first stage in being able to predict where a thunderstorm will build up, so that you can later be able to predict not just the thunderstorms, but also the tornadoes. We're making progress. We're just not all the way there. Oh, Astro YYZ, I am jealous. I have yet to see a solar corona. Now, this is not playing. Let's see if I can get this to play. This is our first set of images of the asteroid Bennu as taken by the OSIRIS-REx spacecraft, which is run out of the University of Arizona. This little spacecraft that is on its way out. This is Bennu, not Bentu, Bennu. The asteroid's name is Bennu, and in the coming months, as OSIRIS-REx gets closer and closer, the team is going to be, well, following in the lines of what Hayabusa's team did for that spacecraft. They're going to be working to figure out exactly what the surface looks like, to map out where exactly is it safe to do a touch and go, and exactly what rock from OSIRIS-REx do they want to bring home. Now, this isn't exactly a landing. This is much more of a go in, grab something, and jump away. The best way I have of thinking of it is if you've seen any of those spider capture things where you go in, you grab the spider, and you lift off. This is going to do the same thing, but with a rock. And I, for one, am, well, eager to see this little spacecraft do its thing. Thank you, AstroWise. I hope to see a total solar eclipse one day, too. Now, that was as the sun continues. I think at this point you're just seeing reflections of my room. As the sun continues to cause weird lighting in here, I think I am... Whoa! Giant text has occurred. Let's see if I can do something with this. Hello, giant text. Working to fix the giant text. And then I will happily take all your questions. Wow, giant text is giant. Okay, that's at least a little bit better. So, looking for your questions. Chat is really being pushy today. It's true. It's true. Wait, Paranor, what were you asking me to embiggen? I'm happy to embiggen something. I think you mean the text got embiggened, though. Yeah, Ed Thompson, I suspect I'm going to be in Carbondale yet again for the 2024 eclipse. Okay, Paranor. So do we have any questions on any of today's stories or on the IAU in general? So Hanny's Wardrobe is asking, would the Parker Solar Probe have been in the eclipse images you showed if it was in place? I have no idea. That is a really cool question. I'm looking for something to write your question. I'm going to email that to myself. That's what I'm going to do. Okay. I will try and figure that out. 24 bits seems to have just appeared. Thank you, Keeper of Maps. That is excellent. Can we get some rockets up in the chat to celebrate? So Paranor's asking, will you have a photo slideshow of your Vienna when you get back? Maybe. The issue I'm running into is it rained all weekend, and while I went out and had fabulous adventures while somewhat damp while riding my bicycle, I was not willing to take my camera out with me while it was raining. I'm hoping that I'll be able to escape one evening this week or tear myself out of bed quite early in the morning. So one of those things will hopefully happen. Unfortunately, it is slated once again to rain on the weekend. So apparently Vienna has it in for me. Okay, so Scott Bragdon is asking, could a coronal mass ejection that was larger than normal destroy any or all of our satellites in orbit? I think that depends on how you define destroy. Could it knock out communications and knock them into safe mode and cause some flushing out of the electronics? Yes. Would it eat them forever? Probably not. And the reason that I say that is back in, I believe it was December of 2005, there was a massive gamma ray burst that occurred when we believe a magnetar star rearranged its magnetic field, and in the process gave off a tremendous burst of energy that was detected as it passed through the sides of various spacecraft. It did cause various detectors to have to get flushed out a number of times. Basically, you just read out the electronics until they stop showing the overwrought pixels. But since that particular very high energy event didn't destroy anything, I suspect that as long as we put things into safe mode, it's not going to crispy critter anything. It's going to not knock anything out of order, out of orbit rather. If we don't have things in safe mode, it could probably fry some electronics, but spacecraft have the ability to go into safe mode now to prevent this. Back in 1989, there were some satellites that got unsafed, we'll put it that way, when there was a coronal mass ejection that also knocked out some of the power grid in Canada. So we're trying to learn better. So Henny is asking, do coronal mass ejections travel straight out from the sun, or do they curve through space? I don't know if 100% of the time, I mean, so they're not going to curve, but I don't know if they come off the sun perpendicular. So the pause is because, let's pretend the lid for my juice is the sun. Now, if I have a coronal mass ejection that comes off like this, it's going to just keep going straight. Now, what I don't know is if all coronal mass ejections are perpendicular to the surface, or if some of them are closer to tangential off the surface. Now, if something is closer to tangential, gravity might cause it to arc off as it goes. But I don't know if this is possible. So the answer is maybe. I don't know. I'm not that specialized. So the way they would curve is if they took off not perpendicular to the surface and gravity curved them back. No, ask the average Joe. I don't know that answer. I do know that our new sun shielding technology is closer in some ways to the thermal shielding that was on the space shuttle than it is to anything else. It's these amazing composite materials that basically stop heat. I'm glad I provided a good answer, Scott. I have no ability to put out fires, Hanny. I bring clouds. I didn't say I bring rain. I do sometimes. And now you have a random rock song stuck in my head. Okay, do we have any other questions? Hello, Bill. I'm glad to see that you'll be at at TwitchCon. I'm going to too many cons and I'm getting confused. So I will be at TwitchCon this year. I will be part of the Communicating Space panel along with Skylius and the good folks at NASA's Twitch. So is there any other questions? If not, I'm going to work on trying to put today's newspaper to bed. Mondays, yes. Today was definitely a Monday. So, once again, the Daily Space is brought to you by CosmoQuest.org. We invite all of you to join us mapping other worlds. I see another question. Guido, I'm not going to make it to DragonCon this year because I like myself. Back during the 2012 IAU, I flew straight from Beijing to DragonCon, and I was coming from the correct side of the time date line, so I gave my talk before lunch. I hopped on a plane, flew to Seattle, landed before I took off, flew to Dallas, flew to Atlanta, and landed right before last call. Now, this time I'm on the wrong side of the time date line, and since I'm the editor-in-chief of the newspaper, I need to see it through the end of the day. So I decided I'm not going to push myself to try and do both. But Mika McKinnon, who has been here with me as one of our editors, she is going to take off early in the morning on Friday, and she will be at Dragon Con. And any of you out there who are at Dragon Con, go talk to her and find out more about her inside scoops on the IAU. Yes, Paranorm, making last call is very important. Yes, Megalyn, health before con. So Henny is asking, are there any important astronomical things in Vienna? Well, Austria in general lays claim to Kepler. It is one of the major countries that he lived in, along with what is now the Czech Republic and what is now Poland. But in general, in terms of like the kinds of things you read about in history books, it's not home to things like that, but it's full of old roots from a time when astronomy was a gentleman's endeavor and civilized people put time into understanding the heavens. There are old observatories. There are more observatories than I've encountered in any one large city. The city's just dotted with them. And they're places that people go to hang out, like coffee shops. And that kind of cheers the soul. There's a globe museum here that has collected globes from across time. There's, at the big amusement park, there's also a planetarium. So it's an astronomy-rich city. There's historic sundials. It's just not filled with those world history turning kinds of places. It's a cool city, and if you do come, Keeper of Maps, or to any of the rest of you, it is a very bike-friendly city, and I'm really enjoying getting around that way, and I'm quite amused that, according to Google Maps, public transit times and bike travel times are almost the same. Thank you, SB Average Joe. That makes me happy. Yes, Doppler was Austrian as well. I don't know what city he's from. We do have some articles that we're working on about not just astronomy around the town, but famous astronomers. So these are the things that we're working on. Okay, looking to see if there's lots of nifty looking telescopes, Keeper of Maps. The University Observatory is actually one of the oldest around. It was, for university observatories, it was built in, I think, 1882, I want to say. It's 10 years older than my house. Okay, so I think he finally finished asking questions. So yeah, the Daily Space is brought to you as part of CosmoQuest.org. We are a collaboration dedicated to putting science in your brain, and we invite you to not just learn science, but to also help us, well, do the work that computers can't do and go in and look at planetary science data and help us map out the scientifically interesting places and the safe places to land a spacecraft. So I hope to see you all over at CosmoQuest.org, and if not there, check out astronomy2018.cosmoquest.org and read all about what's going on right here at the IAU. As always, we have lots of different content that comes out here on our Twitch channel, so give us a follow. Find out when anything and everything goes live. I will be back probably the same bat time, same bat channel tomorrow, and I hope to see all of you here with me. I'll talk to y'all later. Bye-bye.